Hi everyone. Through this class, we are going to study about ocean thermal energy conversion and fusion energy. The ocean thermal energy conversion or OTEC system uses the small temperature differences between warmer ocean surface layers and the cooler deeper water to run a heat engine to generate the electricity. Energy from the sun heats the surface water of the ocean. The temperature difference between top and bottom is of the order 20 degrees centigrade to 25 degrees centigrade. Smaller the temperature difference, smaller will be the efficiency. For typical ocean temperature differences, the efficiency is around 6% to 7%. Warm surface water is pumped through an evaporator containing a working fluid. The vaporized fluid drives first turbine or generator to produce the electricity. The vaporized fluid turned back to liquid in a condenser cooled with cold ocean water pumped from deeper in the ocean. In addition to electricity production, OTEC systems use salty seawater as the working fluid, and we can use the condensed water to produce desalinated water. There are three types of OTEC systems. They are first one closed cycle, second one open cycle, and third one hybrid OTEC system. Closed cycle system use fluids such as ammonia having a low boiling point as the working fluid. Warm surface seawater is pumped through a heat exchanger to vaporize the ammonia. The vaporized ammonia is used to drive the turbine to generate the electricity. A second heat exchanger pumped with cold water condenses the vapor into a liquid and the cycle is repeated. Open cycle OTEC uses warm surface water directly to produce the electricity. The warm seawater is pumped into a low pressure container to boil it. The expanding vapor drives a low pressure turbine attached to the generator to produce the electricity. The vapor is free from salt and other contaminants. This vapor is then condensed into fresh water in a heat exchanger where cold water is pumped from deep sea. This method produces desalinized fresh water suitable for drinking and irrigation in addition to the electricity. A hybrid OTC system combines the features of the closed and open cycle systems. Warm seawater enters a vacuum chamber and is flash evaporated, similar to open cycle evaporation process. The steam is used to vaporize the ammonia, the working fluid of a closed cycle. The vaporized ammonia then drives a turbine to produce the electricity. The water steam condenses within the heat exchanger and provides desalinated water for drinking purpose. At present, only one OTEC plant is in operation, which is in Japan. Advantages. The power from OTEC is continuous, renewable, and pollution free. Unlike other forms of solar energy, the output of OTEC shows very little daily or seasonal variation. Drawing of warm and cold seawater and returning of the seawater could be accomplished with minimal environmental impact. Electric power generated by OTEC could be used to produce hydrogen. The disadvantages are capital investment is very high. Due to the small temperature difference between surface water and deep water, the conversion efficiency is very low. That is about 3% to 4%. Due to low efficiency, high capital costs and maintenance costs, it is uneconomical for small plants. Our next topic is fusion energy. Fusion reactor or fusion power plant or thermonuclear reactor is a device to produce electrical power from the energy released in a nuclear fusion reaction. Nuclear fusion is a reaction in which two or more atomic nuclei are combined to form one or more different atomic nuclei and subatomic particles like neutrons and protons at extremely high temperature and pressure. The difference in mass between the reactants and the products is converted into a large number of energy. The energy E and mass m are related through Einstein's equation E equal to mc square. As an example, we can consider the fusion of deuterium and tritium. During this reaction, one deuterium and one tritium fuses together to form one helium and one neutron. And it releases energy equal to 17.6 million electron volts. Chemical reaction is like this. Fusion is the process which powers the sun and the stars. The temperature at the center of the sun is about 15 million degrees Celsius. In order to replicate this process on Earth, gases need to be heated to extremely high temperatures where atoms become completely ionized. Scientists have developed devices which can produce temperatures more than 10 times higher than that in the sun. To reach such temperature levels, there must be powerful heating. Moreover, the thermal losses must be minimized by keeping the hot fuel particles away from the walls of the container. That is achieved by creating a magnetic cage made by strong magnetic fields which prevent the particles from escaping. For energy production, this plasma has to be confined for a sufficiently long period for fusion to occur. The most developed configuration at present is the tokamak, a Russian word for a torus-shaped magnetic chamber. Fusion power is still in early stages of development. Fusion energy has the potential to provide a sustainable solution to global energy needs. Advantages of fusion energy. First one, fusion energy could potentially supply the world's energy needs for more than a million years. Second one, there is no waste produced during the production of nuclear fusion energy. As a result of this, there would be no money wasted in disposing and cleaning of the waste. Third one, it is clean energy source with no emission of greenhouse gases. Fourth one, there is no chain reaction. Fifth one, limitless raw materials for fusion are available. Sixth one, high thermal efficiency. Disadvantages of fusion energy. First one, it will take years of research to explore it on a commercial basis. Second one, commercial power plants are very expensive to build. Third one, it requires extremely high temperature.